Yeah, good evening, everyone. I'm Alaa. I work as a senior software engineer at Delivery Hero, and today we will be talking about scalability as Delivery Hero way. And yeah, this is me, and this is the social networks. The points which we'll be talking about scalability issues. Every engineer loves to have scalability issues and think about how to solve these issues, how to debug it. But everyone hates when it happens, and he didn't very well prepared for it. Um, there is scalability at the tech hipsters style, and we will talk about it and how to identify these issues and the different styles of scaling. And we will talk about how to monitor and have some logs and metrics about application and help you with scalability issues and how we do monitoring about in Delivery Hero and how to identify database issues like slow queries, how to optimize this. And we will talk about the request queuing, which is we suffered a lot from this in Delivery Hero, but it's getting better. And how we manage releases, how we do load tests and night labels, and finally the scalability framework at Delivery Hero. And at the last point, I'll share a use case for a production issues that we have, which will be really interesting for me. Everyone has an application that crashes from time to time, and it's really bad. But sometimes we really like to have this scalability issues. For example, if you search about Instagram, how they launched it, when they launched their applications, I think I don't remember the name, but the founder waited to see the servers are down, and server weren't down, and he slept, and in the morning he didn't see the servers down, and he was really sad. Guys, why I don't have scalability issues? No traffic. So they waited for the first failure, and I think it happened after the first 10 days. So sometimes this scalability issues gives you good metrics that your application is really good and having too much traffic, but for tech guys, it's not really good thing to have it. Um, for engineers, when someone says, hey man, I have this scalability issues, this request used to take, for example, 300 milliseconds, and today it's taking 600 milliseconds. Can you help me with this? I'm pretty sure that you will leave all the tasks that you are working on and you will really concentrate on solving this issue and debugging this issue. So if you was really well prepared for having scalability issues, once you have it, it will be really lovely and you will really like it. But if you was not very well planned, you will find your servers are getting down and you are stuck and you have to solve it, and you shouldn't wait for it. So do we need to plan for it or just wait for it until it happens and then solve it? We will see. So um, for the not really big applications, when you are asking 3 or 4 guys working on an application, guys, we have this scalability issue, what should we do? The first thing that you will ever hear if you are a back-end engineer, let's do it in Golang. It's a very famous thing. Let's change the language. And the second thing, man, let's add more servers. It will work fine. Or maybe we should go for microservices. We could scale and our application would be very good. So this is, I think for me, was the main 3 points that I hear. But this is not the thing. When someone says, man, I have a scalability issue, I have this bad thing about this request, you should first say, let's sit down and identify the bottleneck of the system. What's going on? It used to have, for example, 300 milliseconds, and now it's taking 600 milliseconds. And we didn't change anything. What's going on? So to identify this, you should first start by reproducing this on staging or on testing environment. I should reproduce it, and then I should monitor what's going on, and then I'll identify the issue. Maybe it's slow query, maybe we need to add more servers, just add more servers and it will work. Maybe it's something about your Nginx and you don't need to change anything in your code, or maybe there's a memory leak or something, maybe some bots are crashing. So when you decide that this thing will solve your issue, you should really have strong opinion about the thing which is causing this issue. You shouldn't just say, hey, let's add more servers or change the language or change the database. This kind of changing is very costly. So whenever you have scalability issue, you need to solve it with minimum cost, because you want to go to production and test it very fast. You don't want to keep working on something for 1 month and the servers are failing, and when you ship this solution to production, it's not even working or helping you fix this issue. So are the steps to identify the bottleneck. Um, when we are scaling our system, we have two types of scalability, something horizontal and something vertical. For the vertical thing, you have your machines. For example, your system is running on 10 machines. You will keep running on 10 machines, but you will be adding more processing power or more memory. For horizontal scaling, you are adding more machines, and this is the Kubernetes way. You could say I have this traffic, and there is some traffic is coming on, and Kubernetes keeps adding this pods depending on the horizontal pod autoscaler. So I think this is very familiar. And metrics and logs should be really your very close friend. You should always have some kind of mechanism to monitor your application and monitor your servers. So you should really define a good mechanism for monitoring your application and monitoring your servers. So if you don't have metrics or logs on your production environment, you will never know what's the issue. You'll never know how to solve it. It will be just guessing. So this is the first step to work on a scalable system, having metrics and logs for everything, for the application and for the infrastructure itself. So if we are talking about the logs, I would say everyone would say yes. The logs for my framework, it has this log file, and should I keep watching this log file, or what should I do? Um, for example, you maybe have no bad logs in your application, but the system is not really good. For example, in Delivery Hero, we used to have specific traffic, and in 3 months, the traffic has been getting higher until we reached 600 times of the traffic for what we have, and this happened in only 2 months. So for example, if we are getting 600 requests per minute, after 2 months we are getting 600,000 per minute. So if you have something like this, your application logs will not really help you to identify the issues. You need to add something like threshold for the number of orders you are getting every day. For example, when we have an issue, it's always being notified by the marketing team. They say, guys, we used to have this number of issues per minute, this number of orders per minute, and we are getting less. Is there something technical going on with your servers or something? So have defining some logs or some stuff like this, which says that the application is misbehaving. It will really help you to know the technical issue even before it happens. My application behavior is 1, 2, 3, and it's not doing the same behavior, so it's misbehaving. So you know how it works. And once you know the metrics that you define for your application, you can add some kind of custom alerts. For example, even in Delivery Hero, we have this. If we used to have 100 orders per minute and now we are having 70 orders per minute, there is some kind of alerts which is firing for and notifies the tech team and the marketing team, and everyone in the company knows there's something wrong going on. Maybe we have a maintenance, maybe we have something wrong going on the servers, but having some kind of metrics that defines the application behavior will really help you to define the issues before even it's happening. So in Delivery Hero, we have this monitoring culture. For example, each team have one guy per week who is doing monitoring. How it's done? For example, I'm working for the payment and checkout team, and we have like one of the back end engineers responsible for doing monitoring for a whole week. This is not a full-time monitoring, but you are, for example, checking the logs every hour and saying if you identified something which is not being shown in the alerts. For example, um, we have some kind of Redis timeouts. We used to have a timeout once per hour, and we are getting 4 or 5 timeouts per hour this week. Why this is happening? It will not be appearing in alerts, because alerts will fire, for example, after 100 of timeouts, so it will not be showing in alerts. It needs one human guy who is checking with his eye and saying this number of timeouts is really increasing. So if you follow this mechanism of monitoring, you will not wait until you have all your Redis clusters down and say, hey, I have a problem with this. So we are having one engineer per week who is checking logs. The logs checking is being done randomly. For example, he is opening the Datadog dashboard and say, oh yes, I found some issues here. And he is after the end of the week, he is writing a report for what he noticed in the logs. And for also the one who is doing the monitoring is responsible for um, refining the resource usage. For example, we add 100 of gigabytes for this application, and he says, guys, we are using only 20 gigabytes. Why we are adding all this? So he might reduce the resources and refine the usage even of the resources. So he's just adding some suggestions for this, and we are discussing this later with infrastructure guys, and we are checking with numbers if we could reduce this resources usage or not. And we have every week in Friday, we have this stability meeting in the morning, which is we say, guys, we have some stability issues. We have this Redis timeouts. We have some bad logs going on in this system. We have communications going from this service to service, and it's happening a lot. We need to reduce it. So we have this stability meeting every Friday morning, and it's really helpful. And one thing I missed to add, he is responsible for running the load tests, which I will tell you after a minute. Also, when you are talking about scalability, we shouldn't miss the slow database queries. I think in delivery here we have some of these slow queries. So you need to really identify these slow queries before it's being the bottleneck of your application. If the database becomes the bottleneck of your application, it's not really fast solution to fix it. So you need to really identify the slow queries. Slow queries shouldn't be affecting the behavior of the system. The system is really doing good, and the orders are really doing good, but it's taking more time day after day. So you need to identify this kind of queries and know how to exactly optimize it. And when we are talking about optimizing slow queries, we are not just talking about adding some more indexes to your database. It's not done this way. So you need to identify this type of slow queries and think how to improve it. You might even not identify the slow queries and just say, I will add some indexes. You might even use some better tool. You might add some caching mechanism, or maybe use Elasticsearch or any other technologies that could help you. And when we are talking also about databases, we shouldn't miss talking about latency between replicas. You might have a read replica and write replica. This write replica keeps writing, and the read replica is failing because there's maybe 1 or 2 seconds between replicas, and it's big issue, and we used to have it also. And you need to identify the access type of your application. For example, when we say we have this microservice and it need to have access on the database, the first thing that the engineering manager will ask you, does it need read access only, or write access only, or both, and why? So you need to identify the access type of each of your application, how it's accessing the database, because you might have this issue of latency between replicas. You might have too much writes, and there's another endpoint which is reading from this database, and there's latency between replicas, and you might end up having an issue which is really super hard to debug it. For example, you have one write replica and one read replica, and you are writing to this replica, but you are trying to query the things that you did write, and it's not there in the database because it needs 2 or 3 seconds to be available for read. So this issue is it's really weird when it happens on production, and you couldn't really identify it until you have really high traffic to identify this. So you need to define what is the latency between the two replicas, and will this really affect your system, or it's okay, you shouldn't really care about this. So that was for this. And one of the main things that causes too many issues, and we used to suffer from this in Deliver Hero, is the request queuing. And what is request queuing? Request queuing is when you are having this HTTP request coming to your servers. But for example, I will talk in PHP. If you are having this request coming to Nginx, and Nginx will see if he have one of the PFM workers running, and he will forward this request to one of the PFM workers. And you might end up having no all the workers busy, so your request will keep waiting until you have one of the children or one of the workers ready to handle this request, and he is waiting all this time until there is one at least available worker. So you need to really identify this request queuing issues, because you might end up having a very big request queuing time, and the clients will start timeouts, and you don't know why it's doing timeouts. And when you are checking your logs, there's no failures. All the requests which is received by PHP are handled. So what was the issue? Why is there's timeouts? And when you are checking, you have big number of requests which are stuck in queuing. For example, this request is showing that there is 207 milliseconds. The request is waiting all this time to get processed. So you need to really identify the request queuing, because if you rely only on the logs, you will not find any errors related to this. And the most hard part in the scaling is releases. If you are talking about Deliver Hero, you might be having at least 10 releases per day. So if you are releasing something that will affect a big number of users, for example, we have every day 2 successful million orders. If you have a specific issue in one of these too many services, it will really affect your numbers. How could you confidently release a new version of your application without saying I will fail for 100 100 users or some number of users? You should be really taking care of your release process. So if we are talking about releases and Delivery Hero, for each service, we have specific times that we could release on. For example, if we are releasing something in Pakistan or Bangladesh, we are asking the marketing team about the peak time for these countries, so we don't release something on peak time. So we are releasing in good times. And we also do canary deployments, and canary deployments means that if you are releasing any feature, even it was not really big, you are releasing for a specific number of users, and then wait and check your logs. If it's doing good, you add 10 more percent or 5 more percent of users until you reach 100%. So when you reach the 100%, you are super confident that it will go right. It will not take your servers down. But sometimes it does. It do. And that's what I was. Yes. If we have a specific failure, we need to know if this failure related to my last release or not. So it's really good to have something that says in your logs, this failure happened on this specific release tag. So for example, in delivery here, we have something called logging context. The context of the log includes the country and the identification of your application, because I think we have 35 different applications. So you need to know which one of this application is causing these failures, because sometimes you are having these failures only because of this client stop sending you specific argument or a specific parameter. So in your logs, you need to really know whether this happened after the specific release tag, whether this happening only from this country or even from this application or even from this platform. Is it happening only from Android or web or iOS? So you need to include this variable data in your logs. And the last thing that we are always encouraging in Delivery Hero, if you are having your service failing, fail alone. Don't fail for everyone. For example, you fail to connect to Redis, so your request will fail. No, don't do this. You should have a fallback mechanism for this. Don't take all the servers down because you have one faulty application or microservices. So it's really good to take care about your fallback mechanisms, and you should fail alone. Don't take all the servers or services down. And load tests. We have this culture for doing load tests. The guy who's doing monitoring is running load tests every Thursday, I think, and it's being done at specific time. And we have two types of load tests. Everyone who is doing monitoring is doing load tests for his service he is working on, and we have another test which being running only in random times. It's we call it Big Bang load tests. It's you are getting all your servers busy and see if the fallback mechanisms of your application is really working. If we took down this service, will all the service will not be affected. So we call it the Big Bang load test. So if we are talking about automated tests, we have, I think, three types: the load tests and unit tests and integration tests. Unit tests should be run after each change in your code. So you have changed something in your code, you need to run the unit tests, and it's being done by the CI. And the integration tests are mostly being run by the QA guys who write the automation scripts and say if this change is affecting something or not. It's doing something like end-to-end test. But load tests, you couldn't really run load tests after each change. It's really costly, and you will never have time for this. For example, in Delivery Hero, to do this Big Bang test, we might take more than 1 hour. So you couldn't really do it after each change. But we do some kind of nightly builds, and nightly builds meaning that you are trying to build your system at night or at specific time, which is non-peak time, and says if your application is doing the build successfully. And after doing this nightly builds, you might run the load test and say if your application is still doing good or not. One of the big notes that I take about running load tests was always use big machines to run unit tests. For example, we have this application who is always who never reached this threshold, which was 150k RPM. So it always, when we run load tests, is maximum number of requests is 150k per minute. Why it's doing this? Because the machine which we were using to run load tests couldn't generate more traffic than this. And when we used a bigger machine, it could handle more. So always when you are running really big load tests, for example, you need to push 1 million requests with 100k concurrent users. You will not really, you couldn't do it from your machine or even from your staging environment. I think we are using a machine with 365 gigabytes of RAM, and it's 93 cores. So you should really use a big machine to generate huge traffic. We use something called, we rely on something called K6, but we are not using this only. We have this internal tool that built by our engineering team, which called How Pizza. I think this is a German word. I'm not really good about German. And this tool, you are uploading your test to specific S3 bucket, and you are running this how beats and say how beats application is called payment API, and I need to run this specific test. And every guy who is uploading the tests is uploading specific configurations. For example, if I run the load tests for payment API, it will run it on 5 stages. It will generate load for a specific number of concurrent user, and then it has more aggressive load for maybe 100 concurrent users and 3 minutes. It keep going on into stages. So we are uploading the tests and the configuration for the tests to specific SS3 bucket with a specific format that we used to have. And when you run the command, it will pull this configurations and pull this load tests and will run it for you from this machine. So we have abstraction over K6, but K6 is really doing good. And when we are talking about scalability, you should have each team should have his own scalability framework. You don't say, okay, I'll do monitoring and I'll do have some kind of new relic alerts and it's done. You should have well defined scalability framework for your team. For us, we have this main 5 pillars in Delivery Hero. You should always design for failure. For example, whenever I add new feature, which is, for example, connecting to external service, whenever I'm reviewing this or anyone is reviewing your code, he will say, what if this service is down? What should I do? How will my application will behave? So you should always design for failures. You should always have fallbacks. What if I'm trying to connect to Redis and it's not there? Maybe I could fall back to maybe database or any other thing, but you should design your application for failure. You should always say there will be failures. And you should really reduce the interaction between services, especially the synchronous interactions. So for example, if you are interacting with other service via HTTP and the HTTP call failed, you should really reduce this interaction between components and specifically this synchronous interactions, because it will fail the other requests coming along. And you should really define your monitoring and tracking logging infrastructure tools. So for example, we in Delivery Hero are using Datadog and New Relic, and we used to use also Kibana for some reasons. So you should define your logging and monitoring infrastructure, and you should really define when something wrong happens, what should I do? Whom should I contact? Who's in call? You should really define even the process for how to solve this. I have a failure on production. What should I do? Should I call everyone in the team and say, guys, I have an issue, what should I do? It will never work. You should define even the process for when something bad is happening to your production servers, what should you do? You should reproduce using load tests. When someone says, we used to have this issue in production from 3 a.m. to 3:30 a.m. and we have this load and the servers was not really good. And you shouldn't say, okay, let's check the logs. You should first try to reproduce the issue with the load tests. You can say, I have 1K RPM, so I will fire 1K RPM on the same infrastructure and see if I got the same issues. Then let's try to identify the bottleneck. So you should always reproduce scalability issues using load tests. And this is the most interesting part in the meeting is the use case. This is something that we used to have in our payment APIs, and it caused a lot of failures on production. And I will tell you how we identified this and how we solved this. First, we started getting some alerts. I told you about the custom alerts we put on specific threshold. For example, we are getting 30 registrations per minute, and now we are getting 10 registrations per minute. This kind of custom alerts we have in Delivery Hero. So this kind of alerts starting firing. There's something wrong going on, and we don't know what's going on. But the duration was really small. For some incident, it was like 2 seconds or 3 seconds. So we thought like it's not really big deal, 2 or 3 seconds, and the system wasn't even down. There are for some reasons there was 5% of only of the requests were failing. So it's okay. They are 5%. And then after weeks later we started having the same errors again, but it's happening for longer duration. The thing which was happening for 2 or 3 seconds now happening for 2 minutes. So there is really big deal. And the alerts was really increasing aggressively that we couldn't even know what's going on. The application is not scaling, and the bots were stuck in crash back loops, and we don't know what's going on. And when we try to reproduce this on maybe local machines or staging environment, I was closing some bots and killing some bots, and it was really scaling good. What's going on? Why it's not scaling? And the backend team started to run some load tests to replicate the use case, and we run the same amount of traffic for the same number for the same period of time. And yes, we have this issue. We have Redis timeouts, and we have some requests are failing. So to fix this, the first solution that came in mind, let's minimize Redis timeouts. So whenever we have a process stuck in Redis, it will time out and it's done. Redis could handle more traffic. And the issue was really solved, and we have less timeouts. But after some weeks, we have another issue. Um, 2 months back, we got a notification from the CTO, guys, we will be able to have more traffic, and we used to have 1 million of orders or 1 million.2. We will be having 2 millions after 2 or 3 weeks, and by the end of this quarter we will be having 5x of what we have. So are our system able to handle this? And we said, okay, let's do it using load tests. Let's add more traffic and see how well application will work. And every team was doing this on his behalf, and we were doing this for the payment, and the system was failing, and it couldn't really scale. The pods were failing, and it couldn't really scale. So after checking, we saw that Redis was also the bottleneck. So what was the issue? When the Redis was taking down by the traffic, Redis was not working. Redis was down, but we have fallback mechanism for each API. But when we are starting up the applications again, when the application is going up, it's doing cache warm up, and it couldn't really do the cache warm up because there was no Redis. So it will fail until Redis is back. So the bots keeps failing until we have Redis up again, and the bots are green. So we have hard dependency on Redis during the app boot up. So we have all the fallback mechanisms for everything, but we didn't really care about the application boot up. And when we removed the hard dependency on Redis, application was really able to handle, I think, 5x of what we have. So this kind of thinking about your scalability issues will really help you. You should always, when you have any scalability issues, you should always reproduce it with the load tests. And we used to do this in Delivery Hero. We have this code, take it until break it. You keep pushing more, and you keep being aggressive to your application until you break it, and say, why should it did break? Why it was breaking? And check the logs and monitoring, and you will really find really valuable information about your application from this load tests. So always keep monitoring, keep pushing more load on your application, and see how it will behave. And you will really have good insights from this. I'm done, and if you have any questions. Yeah.
Questions? Just a second.
Hi. I have two questions.
Yeah.
The first one about request queuing, how you debug it, how you know that you have request queuing or not. The second one about canary deployments. For example, if you have change in the database schema, how you handle this. The new version have changed the schema of the database and the old version is still working.
Yeah. For Delivery Hero, when we are checking request queuing, we always rely on New Relic, and Datadog also has this insights. And you will see, as like the screenshot I have shared, it will show you that you have maybe 200 milliseconds to have your request handled. So you should really rely on any monitoring tools that supports this feature. And the other thing for having migrations running on your database, we in Delivery Hero have a database for not for each application. Each application has even multiple databases per region and sometimes per country. So for example, we are releasing this new feature for Bangladesh, and we want to know how will this go on. Your code should really handle the request if there was no column. So you should have a fallback if the column is null or the column is not even there. So you should do it programmatically. And even if you are releasing, you're releasing to a specific country and see if it will work or not. And if it goes right, you can migrate all the other countries and it will work.
More questions? Any hands? Yeah.
You mentioned, thank you first for the talk. Actually, it's interesting. You mentioned this inconsistency between replicas, like read and write. How did you guys solve this problem that if you need to write and read in the same time, how did you solve this problem, if you solve it actually?
Look, we didn't really solve the issue, but we have reduced it, because if you are talking theoretically, you will never be able to solve it. But so if you are talking about solving, no, we have reduced it, but we didn't really solve it.
Didn't you consider like using a different tool instead of MySQL, for example?
We are doing something different. For example, if you have this data that you should really access in other service before it's even being written, for some cases we are using something like queues, and you are firing an event when you are writing, and the other application is taking it from there, so you could even access the data before it's being written. So you could solve it programmatically, but in database level, for me, I don't know how to solve it 100%.
More questions?
Okay. Thank you for the session. And I have one question. You mentioned something about not making microservices or the services depending on each other.
Yeah.
How do you solve this? Are you using some kind of like event-driven model, or and what about the HTTP requests between the services? This
Actually,
is like a design model, or?
Yeah, actually, we are using some kind of event-driven model, which is really solving some kind of this issues. But we are always saying we need to minimize the HTTP requests between services. For example, service X needs something from service Y. If you could really handle it using queues or something like this, do it. Don't do the synchronous HTTP calls. Synchronous HTTP calls are really bad and really slow, and you will have latency. If you really need to do it internally between services. And if you could improve it by having something like gRPC or RPC calls, it will be really nice. But external HTTP calls are really costly.
One last question. Anyone? Okay, I have a question actually.
Yeah.
What kind of coffee did you drink while preparing this? This was like one big scale presentation actually.
Look, in Delivery Hero, when you are writing this kind of presentation, you are sharing this between different teams and you are getting feedback. So this is a collaborative effort from the backend guys. And I would say special thanks to George, who used to support me for this. So everyone really helped me with this.
Thank you, and thank you, George.
And yeah, we are hiring if you are interested.